Hello and welcome to the next session, how we run decoupled websites with 110 million hits per month. My name is Michael, or a lot of people know me under the name Schnitzel. I'm the CTO of the Amazy Group. Amazy itself is a group of multiple companies, and we're going to talk about two of them today. One of them being Amazy.io, the hosting company, and Amazy Labs, a website building company. Mostly started with Drupal, but now today also does some React, Vue, and Drupal. So this is really not your standard session. I really feel that we don't share enough knowledge about infrastructure, and so this is my start to change that. I have pretty much everything we do I want to show you today in terms of infrastructure diagrams, stuff like that. And so please ask questions right away. If something is not clear, it will go a bit fast, but please interrupt me, ask additional questions. I really think we should share more how we run infrastructure, and so hopefully you will follow suit and maybe do it as well. So I will use today two main projects that we are going to talk about that we're running. We have many more, but there are two of them that are slightly different but also similar. The first of all one is for a project we did for Ringe Axel Springer, a Swiss company that started in the end of 2016 and is actually one of the big reasons that we have today Lagoon, but also that we run decoupled stuff. So what's special about that is that they had a lot of different individual websites. So Ringe Axel Springer publishes around 12 different publications online, and they had 12 different CMSs. And they wanted to solve that. So, and after figuring out a lot of different ways, we came up with the idea of having multiple decoupled frontends with one single backend. So an editor today can go in, create a content article, and can tell to which frontends or to which publications, how they call it, you want to publish a content. So it can happen that the same content actually ends up on multiple sites. So that runs Beobachter.ch, Bilanz, Handelszeitung, and GoMio today. So if you go one of these sites, they look completely different, but they all are running from the same Drupal backend. And if you go a bit deeper, you can see it's GraphQL, and that's what we're going to talk about today as well. And there are many more sites coming. So the idea is that they can actually now onboard more and more front ends while still using the same backend. So for the editor, it doesn't change anything because they're used to that as well already. And then we have another website called paraplegie.ch for the Swiss Paraplegie Center. That started in 2018, and that is a single front end, single backend. So that's different on how we run stuff there. So the session today I want to look into the infrastructure, the platform itself that runs everything. We look how do we organize and manage code, but we're also going to look into people, and I'm going to show you some of the learnings we had along the paths of that project. But let's dive in. Let's start with the infrastructure. So as our infrastructure, the projects that I'm going to show you and also all the diagrams are based around the AWS objects, but it really could be anywhere. And we actually run in other infrastructures as well. So that can be Azure, Google Cloud. It can also be customized. So it is possible to run it in a VMware or other dedicated infrastructure. The whole system is auto-scaled. That means it automatically monitors the amount of resources that are needed, and if necessary, additional ones are automatically added. So that means we can handle traffic spikes, sending of newsletter, breaking news, these type of things. The system does it automatically. Plus, where possible, we always deploy in multiple availability zones. That means it's actually running in physical data centers separate. So if one data center loses power, there are still two other ones that will take over automatically, which is quite important in very big environments that you need to prove some disaster recovery possibilities, and that's built into the system. So enough talking, let's actually look at it. So this is the infrastructure that we're currently using. At the very beginning, we have some kind of load balancer provided by the infrastructure. In this case, it's an AWS Elastic Load Balancer that automatically is high available across multiple data centers. Pretty much every infrastructure today provides you something. If we don't have it, we're going to build it ourselves, but this is what we have. And then we have these orange groups, and these are the different availability zones. So in this type, we have 3. And in all of these, we have 3 Kubernetes masters, or now called control plane. So they automatically sync each other. So if one of them gets a new object, they will be automatically synced to the other ones. If one of them dies and comes back, they synchronize themselves again. So there we already have the first high availability setup. Then we have the OpenShift routers. You might ask, why do we have why do we have a load balancer and the router? The router is actually the part that does the SSL offloading, and also it actually knows to which of the individual containers that are running later that the traffic has to go. So the load balancer is really a bit dumb. It just forwards the traffic to one of these 3 load routers, and then the router actually do the fine granularity forwarding. If you talk about Kubernetes, you maybe heard of ingress controllers. It's the same, just different words for the same things. And then we have the compute nodes. The compute nodes are the actual servers that are running the containers. And we have always multiple compute nodes. They are spread evenly across multiple availability zones. Plus, we also have on-demand compute nodes. So if, for any reason, the traffic or we need more resources, we can start additional on-demand resources, and we can remove them also automatically. And Kubernetes is the system that actually orchestrates the whole thing. So it realizes when a new compute node comes to the game or to the cluster, it will move pods there. You can also tell Kubernetes, hey, I'm going to shut down that node in 2 minutes, make sure that all the pods go away. So that's what the masters basically are managing all that stuff in here. And so this actually is pretty much your standard setup that you would see in running a Kubernetes cluster. Unfortunately, we need sometimes additional things like storage. And so dependent on, again, what do we have in infrastructure, we use either we use like existing solutions like Amazon EFS for file sharing. But you shouldn't use EFS for anything regarding like Solr or things like that, because it's just an NFS mount, and it's not very fast to run databases or anything. So we just put like Drupal files, JavaScript, and that stuff in there. That's perfect for all the other stuff. We need to find another thing. And so unfortunately, EBS volumes, which would be the other solution beside EFS, you can only mount EBS volumes in the same availability zone. So if I create an EBS mount in one availability zone, I cannot suddenly go to the other one. With EFS you can, but again, you have the performance issue. So what we do is we have a cluster FS in all 3 nodes that synchronizes and allows us cross-region mounting. Cluster FS, yes. Cluster FS. Yes. There are other possibilities. That's what we use right now, and and so you see they in itself use EBS volumes to store their data, but it's synchronized across. And all of that, all the provisioning happens fully automated. So if a new project is started, the project says, I need storage, and automatically Kubernetes will go to AWS and create a new EFS, or talk to Gluster and create a new cluster and mount it in there. So it's all automated. We just need to set it up and monitor it. And then at the very bottom, we have some backup stuff, because you want to back up your things as well. And so like the Amazon definitely, they give you a resilience against data loss, but if, let's say in EFS, your editor goes in and deletes the PDF, it's gone. So you need to make sure that you can handle like hardware or physical issues are handled by Amazon or the infrastructure provider, but the human parts, the human errors are not protected by that. So you need to figure out about your backup solutions, how many times do I back up and all that stuff. We currently use Burp. It's an open source system that is really cool, but that might also change in the future. But that's what we currently use. So we do backups of the whole system. We also do backups of all Kubernetes objects that are in there, because sometimes people delete a project and we need to like a secret has been deleted that shouldn't be deleted and all that type of stuff. So yeah, that's basically what we run, dependent on the infrastructure provider, it's slightly different, but this is pretty much the standard setup that we have and we're very happy with. Let's look at the platform itself. And if I talk about platform, it's everything that helps you after you have your server set up and all that stuff, now to actually all deploy the Drupal site in there. As already mentioned, it's completely Dockerized, it's completely containerized. Everything that we run is running in some kind of container. That gives us resilience, that gives us reproducibility, that gives us a lot of other good stuff. We're using Kubernetes and/or OpenShift. So OpenShift is a fork of Kubernetes by Red Hat, which a couple of years ago when we started, Kubernetes did not provide all the enterprise features that we needed, like separating namespaces, role-based access control, all that stuff. Now, over time, slowly things got into Kubernetes. And so today I would say they are pretty much even in the possibilities. But OpenShift, if you pay Red Hat money, they will also provide you support. So they help you run your stuff. If you have a bug, they are going to be the ones that write the patch, and not you are trying to figure out how multiple hundred thousands of lines of Go code works. And then we have Lagoon on top. And Lagoon is the system that actually takes the Drupal code or any other code and builds the Docker images automatically and talks to the Kubernetes API, creates all the different objects in Kubernetes, it creates the storage, it monitors the deployment, it runs like drush commands for you automatically, and it also informs you in Slack, that type of stuff. So Lagoon is the part that actually connects your code to Kubernetes, because Kubernetes has no idea about Drupal, it never heard of it. It knows how to run a container, but it doesn't know how to run Drupal. So that's the in-between that we're using, and that is also fully open source. And as mentioned already, it's auto-scaled. So Kubernetes and OpenShift allow you to do to monitor the resource usage of your containers, and if they reach a specific level that you define, it will automatically start additional containers. And so there are local answers inside that automatically realize that the new container is coming up and it will send traffic there and all that type of stuff. So the system is automatically like breathing. It's automatically scaling up and down and realizing, okay, do I need more resources? Do I need more storage? Can I get rid of that storage? All that type of stuff. So how does actually a Drupal within all of that look like? So we run within Amazy or within Lagoon. You can define two different types. I'm going to first look at the standard availability, what we call. So basically, each site has a different amount of containers. And so within Kubernetes, you can actually define pods. So a pod can run multiple containers inside. And that's needed because sometimes you need to run the same two containers very closely together. We have that case, for example, for the Nginx and the PHP container. So if you talk about Docker and containers, you want to run one single service in one single container. So Nginx and PHP, two different services, two different containers. But they have the same files. So they both need access to the PHP files, for example. Nginx doesn't need to execute it, but it needs to know that it is a PHP file and send then the request to Drupal. Or Drupal creates a file that then by Nginx is handled. So what you can do, you can put two containers into one pod, and they will always move together. So you're scaling the pods up and down, the pods together start and stop or die, and it will always do the same with the containers. So that's why they are here. For the Varnish, for example, we only have one Varnish pod and one Varnish container. That's it. So how does traffic come in? We have the internet, don't have to tell you about that. We have the load balancer that we saw before. The load balancer sends it to the OpenShift router or the Kubernetes ingress, and that's where the SSL and TLS offloading happens. So that's where also all the Let's Encrypt stuff happens. So we have automated Let's Encrypt support, and that's where all these things happen, and we continue with HTTP. The Varnish does. Reverse is a reverse proxy, does caching. It does not do any load balancing anymore. We don't use any of the features because the load balancing actually happens by Kubernetes internally. And so then we send the traffic to multiple Nginx PHP pods. And that's the first part where the actual auto-scaling happens. So in the Drupal side, the part that really is the resource intensive is the PHP. So that's where we are doing auto-scaling on there. We also have our auto-scaling on the varnishes, but honestly, it's so fast, it never goes above 1 or maybe 2. So, but the Nginxes is where the Drupal is running, the PHP is running, and that stuff. And then, depending on the Drupal site, we have all kind of additional services. So that can be MariaDB, that can be Redis, that can be Solr, what we see here, each of them in one pod. But we also, there is support for Elasticsearch, for MongoDB, for what else you want to use, you can all add over here. And these sites, they are rather standard, I would say, and therefore we have MariaDB in there. There's one special one, the pink one, which is the CLI. So one of the things that we thought a lot is about security. And with containers, we have the possibility now to start and stop new containers on demand. So, and what we do is we have a CLI pod, which also has the Nginx and the PHP, or is a PHP container, but it has Drush, Composer, Drupal CLI, Drupal shell, and all these other tools also installed. So if you actually want to connect via remote, so if you connect to the cluster and say, I want to go to my site and I want to run Drush commands, you actually connect to a separate pod that is started for you in that second when you connect to it, and that's when you then can run Drush and stuff. They always, of course, have access to all the other services, so they can connect to the MySQL, because if you run Drush status or Drush cache clear, you need database access. But that means if, let's say, Drupal get 2 and 3 happens again, and somebody is actually able to take over that container, there's no Drush installed. There's no Composer installed. And also the container actually has no write access to the file system. And so with that, we already have a default security, because that container here cannot be accessed via the web at all. And also these containers cannot talk to over there. So that gives us a huge advantage. If it is ever compromised, we have already like a system that can there. Plus, running Drush and having Composer and all this stuff installed also uses a lot of memory and CPU, and it's just not necessary to run them in the PHP containers. So this is like the standard setup. But of course, we also have like a high availability setup, and it's basically the same, slightly different. What we do is we run of each container at least 2 of them. So we have a varnish pod that we run 2 of them. Then we can add more, and Kubernetes will automatically send the traffic to both of them. Yes, that will give you a slightly less good varnish hit rate, because now you have 2, but in the size of websites that we're running, if you talk about 10 to 20 million hits per day, you will not see that, because after a short amount of time, they will be cached and warm anyway. The Nginx is pretty much the same, and then for the MariaDB, we run a Galera cluster. So that means we have 3 MariaDB pods, and they synchronize each other automatically. The Redis, we have 2 of them. There is possibilities to also have clusters there, and with the Solr the same. So you basically just add 2 of them, so you have resilience against dying of one single pod. Because that's the most important and probably the hardest learning we had when we started, is a pod can die at any time, and it is supposed to. So do not hope that a file that you say that you go into the container and you save, that it's still there, because the pod could restart. We do maintenance once per week, and we restart every single node. So every single pod is restarted during that time. That forces you to build stuff in reproducible manners. And it is, though, quite a hard journey. Like coming from having a server that is running, and like you can go there and you can install a tool, and a week later the tool is still there, doesn't exist anymore. Because of containers, we restart stuff all the time.
Question.
Yes?
Do you also rebuild the containers regularly?
They are rebuilt every time that you deploy. So when a new the code, the Drupal code, is actually put into the Docker image, and from that Docker image, a container is started. So we every time that you build, you push a new code, we redeploy them. If there is a critical security update for one of the containers, we force all projects to be rebuilt. But that's something we do on an infrastructure level, and that actually the customer most of the time doesn't even realize that. So we can like rebuild, let's say the PHP container has an issue, we can rebuild all of them forcefully.
Do you rebuild containers if base images change?
Not automated. So how it works is that we take Alpine images, PHP, Nginx, whatever, from the community. We together and Lagoon add some stuff to it. Like the default PHP image, you cannot run Drupal on it because some PHP modules are missing. So we're adding stuff to there. We also add like an Nginx, we add like default Drupal config and stuff like that. And we publish these images once per week. Or every time that we release a new Lagoon version, which is pretty much once per week, we publish these images. And these images are the base images, what we call them. And then our customers, they use these base images to build their images, which is like with their code. So that's the marrying of the marriage of the code and them together. And then they stay there, and they stay one image. And yes, if we create new base images, we don't automatically rebuild all projects because a lot of them is not necessary. But there have been cases, yes, where let's say PHP has a security patch, then we force them, yes. And we get the changes from upstream. So and it's not happening right now, but there is discussions about security auditing automatically of the images, so that we like run them and we see, oh, there's an issue, and that the forcefully rebuild happens automatically. Right now, it's a manual process. Cool. So, but we talked, hey, we want to talk about decoupled. So let's go into decoupled. How does it work with a decoupled? So all of that we've seen before, no difference. The new part is now over here. So basically, whenever we have a decoupled site, we add additional Node.js containers that run our Node code. And the traffic gets a lot of lines here now. But basically, that's just because that also explains how to run CDNs. But basically, the traffic comes from our clients through the Elastic Load Balancer, and they go to the Node.js service. So to the Node.js service, and in there, the server-side rendering of our Node.js code happens. If that Node.js code needs to access the database, the Drupal, via GraphQL or REST API, doesn't matter, it will then basically go back up, come through the load balancer again, and talk to the Drupal. So that's the whole secret of running the decoupled site, that you just have on the side, you have some additional Node.js containers where the requests are actually go through. There is a bit of special case of the assets. So a lot of times, like the images that are, let's say you uploaded by Drupal, they're handled via another URL, and that URL directly talks to the Drupal. It's just a bit of efficiency that the Node.js doesn't need to like handle also image requests, but it would be totally possible to run everything through the Node.js. And then in terms of React and with server-side rendering, the React actually does then GraphQL requests directly. So your browser does GraphQL requests directly after the whole page is loaded. And then that obviously also goes directly through the same route. So that GraphQL CDN here receives requests from the Node.js containers, but also from the browsers. So they go through the same route, and we do that for caching reasons, which we'll see later a bit how that exactly works. But that's pretty much it. So all the rest of the Drupal is exactly the same. We have the Node containers, they run one container, or Node pods, they run one container in there, and we have auto-scaling there as well. Works exactly the same. So we can scale each of the service completely individual. So there is no need to, like if let's say a lot of requests come and the Node.js is very heavy, we don't have to scale the Drupal and vice versa. And I told you before, for the Ringachsen Springer, we actually have a single Drupal backend and multiple frontends. And so the really cool thing there is they're all using the same GraphQL API. So if we actually want to look at one of these sites, So let's go to Beobachter, and let's go to Gomio. So these two sites look completely different. So we see here we have a big title or a big image with a small title and a main title. Blah, blah, blah. They all look different sizes, but they're very similar. When we go to Gomio, it looks completely different. Suddenly, a teaser has a title like before. It has a main title, but it also has a subtitle down here. And we have other type of objects. And that's where we really use the possibility of GraphQL. Because the front ends define what is actually defined in the teaser. The front end goes to Drupal and says, give me a picture, a category, a title, and a subtitle for that site. And in Beobachter, it goes to Drupal and says, give me a picture, a category, and a title, and the subtitle you ignore. And so that allows the whole system to go back and forth. And that's also why these sites can look completely different, can have different menu navigations, can be completely independent. And so what happens is that there's actually two different teams that are working. So there's one team that works in the Drupal backend, migrations and integrations into all the other systems. And there's another team that works on the front end. And these two teams have a contract, which is the GraphQL schema. And so they agree to the schema, how that looks like, and they can now work independently if they want to. What we did, though, is the Beobachter, the Gomio, and the Handelszeitung, and all this other stuff, they are in one GitHub repository because they share a lot of code, as you can imagine. Like all the GraphQL stuff, how to talk to it, and all these things, there's all shared. So we have then all the sites are in one repository. And yes, but how does it look from a hosting point of view? And you maybe guessed it, it's just what we saw before. So this is basically what we had before. We have the Drupal on the left and the Node.js on the right, and now we just have additional Node.js. That's the whole system. So basically for each of these sites, we have again a node pod with Node.js which runs their code in there, and each of them again can completely scale completely separate from the others. And they also can individually deploy. So we don't have to deploy all sites at the same time. If there's a bug only on one site, the developers can decide, I only want to deploy site B, and Drupal is not touched. None of the other sites are touched. So that allows a lot of flexibility in terms of how we develop and deploy and continue to implement features, while the stuff that does not need to be changed isn't really changed. Cool. All right, let's look a bit into how do we organize the code. So usually, if we see a Drupal with one front end, we suggest to put both code in one Git repository. The Drupal backend that is running in there pretty much has GraphQL installed and not much more. It's really interesting to see these Drupal modules pages because we're used to having endless long module pages. You go there, you see GraphQL and maybe one or two, like a migrations module maybe installed or whatever, that's it. Because all the things that we usually do now all happens in the front end. And then on the React front ends, where we have that, we have React as the front end framework, Apollo as the system that actually does all the GraphQL requests. It does the caching, it does all the different things that is necessary, with Next.js as the server system. Plus we have server-side rendering. So that means when you request the page the very first time, the Node server creates all the HTML for you and sends it to you to the browser. If the browser has no JavaScript support, it will not need any JavaScript support. So all these sites, they work completely with JavaScript disabled. Only when the browser has JavaScript support, the React actually will start bootstrap itself and will replace all the links with like React links. And then when you click on it, it will actually do an additional GraphQL request and directly to the Drupal backend. And all of this that I just talked about, you can find on github.com Drupal-GraphQL. So this is actually one of our repository that we use ourselves for bootstrapping your project. So all of this, if you want to look at it, if you want to run it locally, go there, clone it, run Docker Compose up, and you have all the system running. And it shows you best practices around the React and the Drupal and all that stuff. It's biased on GraphQL, sorry, if you use JSON API, but if you want to give it a try, and it's very similar to JSON API. It doesn't matter, like the main concepts of server-side rendering, Apollo, and all that stuff is the same. Let's talk a bit about CI/CD. As you saw, it's quite a complex project, especially for the Ring Axel Springer stuff. For the other project, it's just one monorepo with Drupal and the front end, but still. So what we can do, we can create an individual environment for every single branch or every single pull request. So if a developer pushes some code and creates a pull request, it starts a new Drupal and a new front end with its own URL. So you can test that specific code for, or the changes for that specifically. You can show it to your stakeholders or whatever, and then they can test that. And when they merge the code in, it goes into the master branch, it will deploy as well, and it will deploy the master as well. There's also the possibility that you maybe only have done a front-end change, and you want to now test that front-end against an existing backend, so an existing Drupal site. That's also possible. So via a small configuration file, you can define PR targets. And so you can say, okay, that pull request with that Node.js code, I want to test it against that Drupal backend, because you maybe want to test with the data that you just created in that Drupal site. That speeds up the process of Node.js or of front-end development, because you don't always have to start a new Drupal, a new database, and all that stuff. Yes?
Where do you put that configuration?
I think it's per project right now. So it basically uses, so when you create a GitHub GitHub pull request, you point to a target branch.
Okay.
And the script that starts will check if the target branch has already an environment, like a Drupal backend, and if yes, it will inject environment variables that tells the system where to go. Cool. And then all of this though has no unit tests or behead tests or any other things. So for that, most of our customers use either Travis or Circle CI, and the really cool thing is there. And you can actually start the same Docker containers that we use in production, you can run within your Travis or your Circle CI. And you can use the exact same, you can even clone the database. You could import your production database into your Travis CI and let's say run visual regression testing or other things. So it allows you to test in the exact same environment that will also run later. All of that might be also a bit complicated and to set up. So there's another really cool tool called Drupal. It's a project called DrupalDev.io, and it's basically from Alex, and he's he works in Australia, and he said, okay, instead of like building that every time the same, he published it. So you will find a template for Drupal 8 and Drupal 7 where you can run PHP code sniffer, ESLint, SASLint, simple test, PHP unit, behead tests automatically in Travis or Circle CI. And so it uses the Amaze.io, it uses the Lagoon images to start the containers and all that stuff, but it basically shows you how can you run automated tests every time that you push a commit into your GitHub or wherever you host. The system goes through, tests everything automated, and then it will only start the deployment in Lagoon after Travis or Circle CI actually says this commit worked. And so, because we had many, or there is, of course, like if you have a small issue in your node code and your node cannot start, it doesn't make sense to start a container already in an OpenShift environment or so. So that allows you to do that before. Another interesting thing is GraphQL, as its nature, sometimes is too big for Get. So you cannot send the whole GraphQL request through a get parameter because it has some limit that I just forgot, but at one point it's too big. So what it does, it uses post. And if you read the HTTP spec, there is nowhere it says post is not cacheable. Post is by standard cacheable. Unfortunately, many CDNs and cache systems, if they see post, they will never cache it. So you have a problem, you cannot cache. GraphQL request caching is by default very hard. It changes now slowly. Fastly has support now, Varnish has support now, so it gets there. But it's still quite a thing. So the solution is called persistent GraphQL. So what this means is the front end, when you build the front end, it creates a query map. And the query map is basically a JSON files of all possible GraphQL queries that this front end will ever run. So the front end looks through its own code and analyzes it and figures out all GraphQL queries that will ever be ran, no matter where you click. And in that JSON file, it will put all these queries, and also each of the query will get an ID. It's just a hash of the query itself. But basically, so you have a file with all queries and an ID to it. And that file will be sent to the backend. In Drupal, there's multiple possibilities how you can do that. There's a REST endpoint, or there's a GraphQL endpoint. You can also just, because in a monorepo, you can just commit the file, like we commit Drupal configuration. You can commit that file as well. And then the front end will do requests via GET, and all that will be in the parameter string will be the ID of the query instead of the whole query. The Drupal then, or the backend, will look at the query map, compare the ID that is in there with its actual with the file. It will see the whole GraphQL request. There can be multiple thousands of lines. Don't do that, but you could. And it will then actually run the request with that query as it would have been received from the front end to the back end. And the really cool thing is, you can actually disable on the GraphQL endpoint, so in Drupal, you can then say, I only allow requests with valid IDs. Because as cool GraphQL is, it also gives a lot of power for somebody that figures out how to run your GraphQL. So this allows us to not allow any post requests on the public available GraphQL endpoint. We can also say only allow these IDs. So if somebody wants to create something else, they can't, unless you maybe allow it. Now, again, sounds complicated. It's also on the Git repository. So in there, it shows you how that works, how you create the persistent GraphQL, the file that you can upload to Drupal, and that type of stuff. And so that solved for us the problem of post. So all GraphQL requests run through GET now, and you can now cache it with any available CDN with Varnish, no problem at all. So that's when you read published blog posts on the internet. A lot of people complain about that, and it solved it for us pretty much completely. Like, it's not something we worry about anymore. Okay, we talked about infrastructure, we talked about code. Let's talk about people, because at the end, somebody has to write the code. And usually, at least in our case, it's still the people. So the first thing is we have strict pull request-based deployments. If you have a project like that where you have a lot of different sites, or even the smaller site, we just have a front end and a back end, because you have now two systems that are dependent on each other sometimes, you cannot just push one. You cannot just deploy into production anymore. Like, you shouldn't do that anyway, but it's just so it's really strictly, we always go via PR. The PR creates an environment, that environment is tested, then the pull request is accepted, and then we go in there. The next thing is, we actually do PagerDuty schedules with the developers themselves. So we, as a hosting company, it's quite, because it's such a big project, sometimes when they deploy, our PagerDuty says, yeah, like there is a problem with the site, but they just deployed. So what actually happens is the PagerDuty is first sent to the developers, If nobody of the developer picks up because they're maybe sleeping, which is fine, or they are not there, then it comes to us. So we have 24/7 staff that actually look at the PagerDuty, but that solved a lot of problems because they can deploy it anytime. They actually deploy it anytime. And so we had a lot of issues of us getting notified. And you can imagine, like, everybody jumps there and tries to figure out what is the problem, and they just said, oh no, we do maintenance on the Drupal side, it's fine that the whole sites are down. It's like, okay. So giving them the PagerDuty first, and giving them the possibility to alert it to you solved for us a lot of issues. And then the last thing, all of us are in one Slack channel. So that means all the Amazee.io system engineers, the ones that are on staff, the project managers of the customer side, the developers, their bosses. We have one big channel with like 50 people. And in there, we can discuss stuff directly. Because a lot of times when something is down, and I will see later some of the anecdotes we had, it's really important to be able to communicate quite fast. Because the front-end developer maybe did a change that the back-end developer didn't know about. And so like these issues you can resolve quite fast if you have a fast communication. So let's go to the learnings. What did we learn over time? So the title of that learning is Node.js as a web server is hard. So a lot of the developers that worked on these projects with Node.js come from a Drupal world. And in that world, it's not common that the code that you write, aka the PHP, is also the code that actually serves the website itself. Because we know we have PHP and we have Nginx, or Apache. And usually that's the part where like cache headers, redirect, basic auth is handled. In a Node environment, Node with Express servers can do all of that themselves and actually very good and very fast. But the concept of understanding that now if a cache header is broken or not correct, that there is no Nginx that you can go in and fix it, or if you want to have a basic auth, that you can write it in the Node.js itself. That took some time for everybody to understand and realize, oh, there is no other system in front of me. Like in PHP, we always think there is an Nginx somewhere that does magic stuff or so. Interestingly, for that project, actually, we had so many redirects. There's like 35,000 redirects or so because of SEO reasons of the old site to the new site. We ended up adding an Nginx in front of it again. The fun part was we never knew as an infrastructure team that this happened because they can do it themselves. They can just add a new container to the system and change the routing. And suddenly at one point I logged into the front end and I saw an Nginx. And I was like, what the hell? And then you go in there and say like, oh, okay, yeah, no, we do now the redirects in there instead of the Node.js. And it's like, okay, great. So they solved the problem themselves with adding a container again. But that's something that like in the Node.js world, you don't have by default an Nginx or any other web server. Yeah, so they did that. They have an Nginx container with a Node.js container in there. The next thing about persistent GraphQL. So persistent GraphQL is awesome and it's cool, but allow post requests on your PR and dev environments. So as cool as the system is to have to force only persistent GraphQL queries like with the IDs, we learned that on dev and PR environments, it can be a pain. Because the front-enders, they maybe change something in the GraphQL, they forget to commit the GraphQL or the query map, they push it, it goes to the site, they visit the site, it doesn't work. And then like trying to figure out where exactly the issue is and stuff like that, it's much easier if you just allow post requests on your development environments where you just want to test something real fast, because you're going to save a lot of pain yourself. And also make sure that you test them. We had one case where the tests didn't check if the persistent GraphQL is valid. And so we always pushed the wrong one. And it took us probably like an hour or two to figure out, like, because you have to site this down. And you're trying to figure out where exactly your stuff is and all that thing. So write tests for them, make sure that they work, that they are correctly validated. It's going to save you a lot of pain in the future. Then, complexity as a service. It is complex. Yes, I'm talking about multiple million Swiss franc project. Like it's not your regular project that you just do with regular site. But we are using it also now for smaller projects. So we went really big in. We had a lot of learnings, and now we also use it for smaller projects. But still, it is a bit more complex than your regular Drupal site. And this actually focuses on another stuff. If you use an external service, in our case, we relied heavily on an external CDN. And make sure that you understand what that CDN can do and what not, as good as you understand what your own application can do and what not. Because a lot of times, when something was broken or didn't work, we didn't really know, is it now a CDN issue or is it an issue of our services? And yeah, like a lot of times it just worked in the PR, and the PR didn't have a CDN in there. So of course, the immediate thing that you do is you immediately blame the CDN and you try to solve it there. And so one of the things we had downtimes where we believed it was the CDN, but we couldn't reach anybody of the CDN team and ask them if is everything fine on your side. So we had to figure out ourselves, is now the problem over there, or like in which direction do we need to search? So if you build anything and you depend on an external service, make sure that you have access to people or the resources of these external services. Because there might be a situation where you're not sure if the service is the problem and having somebody to call or send an email and you get an answer back and saying, no, on our side is all fine, removes the issue tremendously. So with that GraphQL, persistent GraphQL that I talked before, for most of the time we believed it's a CDN issue. And we spent a lot of time there and we tried to like bypass it and that stuff until we realized it's actually not, it was another bug on the other side. So yes. And then crisis communication is key. So as you can imagine, running a site where 4 websites, soon 5 and 6, run one single Drupal backend. If that Drupal backend goes down, now 6 sites are down. And so one of the things that we learned is whenever something happens within Amazy.io, we have one engineer which is dedicated to communication. And that person's responsibility is to protect the other engineers that are fixing the problem from anything going to them. If you ever looked how NASA runs stuff between like the ISS or any spatial, they do the exact same thing. There is one person that communicates with the other team, and we try to implement the exact same. Plus, also make sure that you have chat systems where you can like say, you can write an add here in there and say like, we're gonna redeploy the front end. And everybody can see that. A lot of times we had to tell like 7 different people what is gonna happen next. And that used so much, we spent so much time in communicating than actually solving the problem. So that really helped. Plus, we now also have an internal status page for the stakeholders. So if something goes down, we can publish it there and say we're working on it. Because you can imagine if 70 or 80 people are working on your Drupal site, you will get 80 to 100 emails when something is wrong. So if you know about the first one, you publish it there and you teach all these people, read the status page there first. That helps you a lot of like reduce the amount of stress. Because nothing is worse when you're trying to fix a problem, people telling you that there is a problem. And that uses a lot of your brain capacity and a lot of time. So that's really what we see is, or we learned a lot about that stuff, and that's what we're implementing today. That's it. Any questions?
Yeah.
Yes.
You said that the super tickets goes first to the developers and then to the support. That doesn't make like the developers lose focus on what they do.
So a lot of times they are actually the cause of the issues. So like they're deploying, and a lot of times doing with Drupal, unfortunately, if you run a cache clear, sometimes it takes a bit long, and our monitoring system sees that. Like if the Drupal site is not responding within 30 seconds, our monitoring comes and says like there's something wrong with it. But the developer knows I just deployed, there is a cache clear or a cache config import running, and so it is fine. So that's what I'm saying, that most of the time they are the issue. So they are doing an act on the platform anyway that causes the monitoring to alert.
So I guess you just do that in the projects that they are working on. It's not like...
Yes, no, correct. It's only the developers that are working on it. So within PagerDuty, you can create schedules and who is on call and all that stuff. And so they make sure that the person that is currently the person that deploys is also the person that receives the PagerDuty. It's not like that they suddenly receive a downtime message from another project that they never worked on. So like it's not operations.
They never work, but maybe 6 months ago they were working. That's a change of focus. And give that ticket to the developer.
So, okay, that project is maybe a bit special there because they only work on that. Like that's one dedicated team. I agree. If you have an engineer, like for other projects, we don't do that. Like for let's say for the Power Plug project, for example, yes, the developers that worked on that, they now work on another thing. There, it first comes to us, and then we decide, do we need to alert? But for that project over here, they are deployments every week. Like they change stuff every week. So it's a team that only works on these 5 or 6 sites. So you don't have the problem of like a person didn't work on it anymore. But I agree, it would be a bad idea to just send for every project to send it to the developer that maybe worked on it at one point. Correct, I agree with that. Other questions? Yeah.
For example, in backend, you need to make first changing the data model or something. What happens to all that stuff that needs to be rebuilt? For example, update the DB or something like that. What's the secret of the...
So the idea about GraphQL is, first of all, the schema should not change. You should not change existing fields. You should add existing fields or add new fields. So the schema is actually versionless, which means if you add a new feature, let's say one site needs now also an icon. And you add that icon, you run the drush opdb that adds the icon as a field in there and all that stuff. Because all the other sites that never heard about the icon, they will never request the icon, therefore it will not break. The other thing is, though, is cache invalidation. So you need to tell the CDNs and all your caching layers that if you change let's say, like there's one tool where the editors can create their start page. Like they can move stuff around and decide what is now the top story stuff. And every time that changes, you need to tell the CDNs, hey, or your caching layers. And we use Drupal cache tags for that. So the cache tags are sent to the CDN, and then you tell the CDN, hey, node 700 has changed, and then the CDN will remove the cache for that specific node. Good, that's it. If you have any more questions, I'm still here today and tomorrow. I'm happy to share more how we do stuff, and yeah, enjoy your fondue tonight. Thank you.